The first thing we wanted to share was why we chose to create a Guitar Hero robot. To start, Guitar Hero is something that is quite difficult for humans to play. It requires us to have excellent hand-eye coordination and dexterous movements. Instead of viewing this as a reason to not create this robot, we saw it as a challenge that we knew we could overcome. Our group decided to make a robot that can perform a dexterous task, aka Guitar Hero, better than humans.
Here's a demonstration of the robot's results. Our model included a Kuka Iwa and a WSG Shunk hand. We modeled it after a pick-and-place P-set that we've done in the past. We made sure to import a SDF guitar file found from TurboSquid. We manipulated it in the SDF raw file to add button frames, prismatic joints with spring physics, and we did this all to simulate a real Guitar Hero controller. Spacing the buttons, welding geometries, and allowing for the prismatic joint to move without colliding with the guitar's around 60 other collision geometries presented a unique challenge. Despite our struggles, we were unable to design our own controller for the Allegro hand, and so we found ourselves limited to the 2 fingers of the Shunk. What we would do is we'd input a note sequence with each note's respective duration. This would send a command to both the Iwa and the WSG controller. The WSG would remain totally open if the 2 notes it was supposed to play were 2 buttons apart. It would be half open if the notes were together, and if it was playing a single note, the gripper would close and it would poke it like that. So if the time between the notes was too small to confidently create a trajectory, the intermediate phases, the pre-press and the post-press phase, were transitioned to make them faster. In the end, our robot was able to play all of the Guitar Hero songs well, although not perfectly. Expert was out of our realm of control entirely, since it usually includes 3-fingered chords. Our robot outperforms your average person, although it is not able to outperform a talented Guitar Hero player. There is a steep drop off from hard to expert in our performance, although easy and medium are often 100%. The following graph has results for slow ride, as performed by a talented player, a newbie, and our robot, of course.
We have 3 main goals for the future. First, we would like to use our same model, but use an Allegro hand so that we're able to play more notes at once and also perform more similar to as a human plays. Second, we would like to integrate our model with the perception pipeline that we have created. For our pipeline, we utilize color segmentation. First, we convert RGB images into its corresponding HSV values. Then, we look for all the pixels that lie within a certain hue range, and we draw contours around them. Last, we draw minimum and closing circles around these contours. This function returns a radius and a center pixel. If the radius corresponds to what we expect for a given note, then we identify that as a note. Then we look at the position of this circle, and if it lies within what we call the strumming range, then we instruct the robot to strum the note. Lastly, we would like to make the transitions of our robot smoother and faster. When our robot encounters rapid sequences of notes, we sometimes experience drifting errors, which would lead to the robot hitting buttons from the side, which further cause more errors, or missing buttons entirely. In the future, we would like to fix these issues.